David, welcome to the HYSKY Pod. I am so happy to have you here. It was also fantastic to meet you in Bromont a couple of months ago, which I never thought I would say that I met the CEO of Robinson Helicopter at a hydrogen aviation event. So I would love to just start off with let's talk a little bit about your career and how did you get started in vertical flight? What did that trajectory look like for you?
Yeah. Yeah. I mean, I did not set out to become a helicopter person, but it arrived in my lap, I guess. When I went to school, I did so trying to become a part of the space program. I really loved space as a kid and wanted to fly the space shuttle. I have epilepsy, and I sort of was diagnosed with that in my junior high school years, and that prevented a lot of my dreams. I couldn't go be a pilot. I couldn't go be a space shuttle pilot for sure. So I ended up going down the engineering path, and in college, my undergrad was at MIT. It's a very, very space heavy program. Some other great connections still to amazing jet engines and things like that. But a lot of the exposure was space. And as I got towards the end of my time there, made application to what at the time were the best options, which were not space. There was no commercial space yet, really, and it was all Boeing for joining one of the commercial aircraft development programs, or I had a family connection that got me interviews at Bell Helicopter and multiple different departments, and I found a really, really great team there. Worked for one of my favorite bosses, Glenn Isbell there. Everybody listening should go hire him if they can get him to move out of Texas. But great team out there, and it was just the perfect timing in getting into that business. They had just, right as I joined, they won a contract. And so I got right in the middle of product development from day one. And that's contagious. I mean, product development is so fun, so much more interesting than school. I'll tell you that.
Yeah, thanks for sharing that. I had no idea that you had epilepsy. So thank you for sharing that. One of our team
Yep.
members, Angela, also has epilepsy. And so I've learned a lot about it from working with her. She's also in Texas. I've heard that story often. As an aerospace engineer myself, I thought, well, we probably grew up around the same era where, Krista McClough and, space was just
Yes.
wow, and it was so cool. And space was just the thing to be. And I talk about this often on the podcast that we need to make science great again and aerospace great again.
Yeah.
Because it was, the thing to do. So I've heard that story a lot. A lot of us aerospace engineers, we wanted to be pilots, we wanted to be astronauts, but we found being an aerospace engineer was kind of the next best thing. And I think sort of just for lack of awareness into what all there is to do in aerospace and aviation, we don't really learn that much about VTOL. You learn a little bit about it
That's
in
right.
college, but it's just barely touched on. It's turbine engines, muzzles, remote, all this stuff.
Wings, a lot of wings, just
Yeah,
wing, wing,
lots of
wing.
exactly. So that's very interesting. It's similar to my path, where I also was working on. I went into industry working on Boeing aircraft and Airbus aircraft on 777s, 737s, A320s, and I was bored out of my mind. And so I'm like,
Yep.
we need to do something cool. And so I started advocating at the company that we should be getting into advanced air mobility. And
Mhm.
I just said the other day on Wednesday when you were after you presented at Flying High, how amazing it was that a company like Robinson was getting into advanced air mobility. So let's talk a little bit about when did you leave Bell and go to Robinson, and did you immediately go to Robinson as the CEO, or did you start out in a different role? And then, was Robinson already looking at advanced air mobility, or did you
Sure.
lead that? Yeah, what did that look like?
Probably worth just a quick. My career, most of my career was in product development, and I got to be part of some aircraft that were really aimed at democratizing the sky. So I worked on was the earliest chief engineer for the Bell 505, which is a light 5-seat helicopter, and it actually got me exposed to Robinson as a competitor. Part of the reason why we were doing the program was to block Robinson from moving up market into Bell's bigger products. And I got exposed to customers who are Robinson customers. I got exposed to the manufacturing and the strategy of the company. And it was a really great experience. We moved very quickly. We were one of the first programs, and probably the only program in the industry that flew early, flew under budget. Ultimately, the program was cash flow positive because they had such interest in the customer base. It was a really big success for Bell. Ultimately, subsequently, the product has gotten very expensive for Robinson. We are now like taking market share back from the 505 and really excited to sort of take over for my stepchild there that's floating out in the world with the 505. Part of that then led me into a stint in a startup within Textron of true simulation and training, where we had bought some companies and bolted them together, rebranded, and came up with kind of this new business model inside of a Fortune 500 company. But I love that. I led their training services division, and then ultimately their business that was business aviation, so specialty simulators. And then at the end, I led the whole division. And then the pandemic kind of destroyed it all. But ultimately, my experience in that was a 5-year kind of side quest, I'd say. Phenomenal experience. Loved having control over both strategy, certainly P&L responsibility, and then a lot of talent selection and customer touch and contact. It was a great experience. So I love that, crave that. After that, though, I went back to Bell and helped them prepare for the U.S. Army contract they just won, which was a very important national priority. So I enjoyed it, but I didn't have that same itch scratched of being directly involved in strategy, directly involved in making big things happen, with your mind. So I picked up the phone a couple of times, I'd say, from recruiters, and several great opportunities that came up. Actually, several in AAM, some that I still can't be too public about, but they were fantastic opportunities in these companies that are trying to figure out how to make distributed propulsion work. And I ultimately, one of the reasons why I chose Robinson over those opportunities was the physics of vertical flight favors the way helicopters are laid out. And that's not a secret. It's 100-year-old, discovery, but it's kind of the reason why bicycles work the way they do. It would not interest most people to put 6 more wheels on a bicycle. So I argue that a lot now, and I think ultimately the opportunity to join Robinson was too great to pass up. They had truly in their history never made any mistakes. They had managed the business really well, kept control of the supply chain. So in a time when people couldn't get basic materials after the pandemic, Robinson had a warehouse full of most of the core ingredients for helicopters, and they make it all here. So really successful company. They hired me knowing that CEO was the job, but to give an overlap with my predecessor, who was the son of the founder, Kurt Robinson. He had a long tenure as the CEO, did some amazing things through the financial crisis, the launch of the R66, fielding of avionics and autopilots and amazing things.
Wow.
And so he made a huge impact, but you could tell he was tired, and like he had done this as a labor of love in a family business for him, and was looking for someone he could pass the torch to. So I came in for a year, studied under him, really learned the business even closer. I took over about a year and a half ago, and one of the major tasks, to the point of sort of AM and alternate power plants, was from our stakeholders and our board was go and be a leader, take the leadership in this space, not just ride alongside so many people, which many people have used our product to develop electric propulsion and hydrogen systems before, and AI systems as well. Lots of exciting unmanned and AI. We should be owning that, and we will. And so that's been a big part of my last 18 months, is to go and actively lead and drive and invest and control.
Wow, so many things come to mind. First, I just have to say, what an incredible opportunity to work underneath the founder's son for over a year. I bet that was magical. That there might need to be a book written about that. I mean, I just can't imagine what all you've learned. And I also didn't know that Textron did startup stuff like that, kind of like their own little incubator. What city did you do that in?
Yeah, so the headquarters was in Goose Creek, South Carolina. It was a place that they had a business that did military training devices, among other things. It was a really nice facility there in Goose Creek. The headquarters stayed there even when I was living in Tampa and the CEO. Tampa was our facility that did both business aviation simulation. They still have that site, and they build a lot of great helicopter sims and business jet sims. And then we had also a training center there that ultimately the training center, we were so successful with the training business, disrupting the training business through some acquisitions and growth, that Flight Safety International, one of the largest trainers in the world on simulated training, basically approached us and did a kind of a buyout, a joint venture ultimately, but a really favored buyout effectively. So it was one of the ways you can be successful, right? You can grow a business to the point where you destroy your competition, or you can grow your business where your competition buys you. And that was plan B. So ultimately was quite a successful, fun ride. And I had going into it, I had absolutely no knowledge. This just tells you how big companies kind of make decisions. They liked the work I had done at other projects before, and they were like, "Here's something completely different." I had no licenses. I'm not a pilot. I had never been in a commercial, training environment. Didn't really know any of the regs, and so it was like really go figure everything out. And it was ultimately a really fun ride with a lot of great people.
That's so interesting. Well, good job on you all and good job at Textron for, thinking outside of the box because, there are ideally every big company would do that, but it's sometimes very, very difficult, right? And in fact, one of
Yeah.
Textron's competitors, I was arguing and advocating that we needed to be doing exactly that, or people like Textron and Honeywell were going to outpace us. I'll leave that comment there, but so good on you for doing that.
It
Doesn't
was fun though. I'll
Textron?
give you an example that,
Yeah.
too many people in training were focused on like the basic problem of commercial aviation is this is just a really amazing trap we've fallen into. Commercial airliners, freighters, and people movers like the airlines in the U.S. They visit and train twice a year in simulated based training. But if you ask the average pilot, does it make you better? Most of them will tell you it doesn't because, and we did this benchmarking with lots of professional pilots that mostly is setting up, do you meet the minimum requirements? Do you meet the thresholds that are put forward by the regulations? So ultimately, I thought that was such a big miss. And right in the middle of that, this is why you bring people in there outside the business and you get different perspectives. I was watching the rise of personalized fitness training, including things like Peloton that were gamified and things like that. And I kept thinking, like, it's crazy that my exercise bike makes me a better biker or better, physical specimen than this entire expensive multi-day trip to places to do simulator training. And so we've approached it from that perspective that we can make people better in training, not just establish that they meet a minimum. And I thought that was such a disruptive thing, and it still is. We're going to do some of that here with Robinson, so I carry that with me. But I think it's the kind of example why you should take risks on people to go and try something, even if they're not eminently qualified in that domain.
I love that story so much. So shout out to all the big companies. Listen, take risks on people, even if they don't know or maybe even have the experience, which something that I see so often, which you have obviously mastered, is engineers really struggling in business. And that was very hard for me at first. When you're, used to getting the right answer or you can figure things out and sort of think or calculate your way out of it. In business, it's like, I don't know what the heck I'm doing. And I'm
Yeah.
just going to try this and hopefully it works out. And then you have to convince other people that what you're doing is right when you don't
Hmm.
even really know if it is, right? And that's really difficult for some of us to do. And I'm definitely still learning. So what do you think was I really am just kind of picturing you going from, lead engineer, chief of product to,
Yeah.
leading a startup and strategizing. That had to be kind of a mental shift. What do you think was the biggest learnings that came out of that for you?
Yeah. Well, I left a piece that's probably important, and I do advocate for this. I considered executive education or follow-on masters, that kind of thing, as a young engineer. Ultimately, I decided to do an MBA while I worked, and I thought it was a really great kind of I'll say crucible where very high pressure. You'd work all week, and then you go. And I'd live in a hotel with a bunch of young 20s and 30 kids that were in a similar condition in their professional life. And it was great because we were able to like really take from the work environment directly into the MBA classes for cases and discussion. And it was so valuable because right as I was doing that, it was right during the financial crisis. During my classes, we had the Deepwater Horizon debacle in the Gulf. We had, in my company, we were doing a massive implementation of ERPs, shop floor MES, and 3D PLM tools for design. So all of that fit different topics inside the program, and we were launching a big new product, the Belt 525. And so because of that, I was able to like really get active in pricing strategies or regional and global strategies, and it was just such an awesome time. I benefited a great deal from luck. I mean, I will say that timing is everything. And I came out at the right time of college. I went in the right jobs. All great luck. I had some great mentors that helped maybe steer my opportunities. But I'd say that my business background came from the mentors that I had, which were excellent, and the executive education I took while I did other important projects. And I thought that was a great combo. So I recommend people go do that. You might think go leave the workforce and go get a 2-year MBA real fast. Honestly, I think that's a mistake. I think giving people I had a great mentor who used to use the word, your career is about surface area. And if you're out of the workforce, instead of doing this sort of, yes, it's difficult, but you do 2 years of work and 2 years of school at the same time, you are doubling your surface area for that period. And there's nothing like that in your whole career where you can double your exposure. And so maybe you get great opportunities from your classmates, maybe you get great opportunities while you're working, but you don't want to take either of the two, you want them both. And I thought that was such a brilliant contribution. Shout out to Vince Tobin, who was my mentor at the time for that. But we have some great. I had some great mentors over the years. You know.
And I love it that you're mentioning mentors. A book that I read, oh gosh, probably a decade, maybe even more, was called Sea of Mentors. And it just talks about how valuable mentorship is in both being one and finding one, and that they all serve a time, right? You will eventually outgrow a mentor because if you want to do more, I mean, you still stay friends with them, right? But they can lead you to this part, and then you find another mentor, and it's just always having mentors. So I love it that you said that. And that is fantastic advice because when I was at that company that I was talking about, I was considering doing my MBA and I
Hmm.
did it. I didn't. I just jumped right in. I was doing my master's, but I really, really, really wanted to do something different. This is around the time
Hmm.
when the two Boeings went down and all of the Boeings were
Oh yeah.
grounded. So we were
Yeah.
furloughed and it was just a sad time for aviation, for especially for commercial aviation, what I was working on. So, I'm at home, I'm doing school, and I'm like, I want to do something else. I want to start a business. But if I had heard that piece of advice, I probably would have stayed longer because what I did and what we don't really think about is kind of, I mean, I still had those contacts from work, but if you're working on something in the industry that you want to do a business in, then you can nurture those relationships from work instead of just pivoting out of there, you know what I mean? And they might even
Yes.
fund it. Your company might even fund that. And that, yes, I did quit and go to work and create a business, but it was so difficult, so difficult. And I
Yes.
I do not wish, I mean, I literally risked everything and it was very scary and I had to make it work or I was basically going to starve. Which, was kind of burn the ship sort of method.
Right.
But yeah, it was scary. And if you can avoid that, definitely increase your area. So those were for sure words of wisdom. So let's pivot a little bit and talk about hydrogen.
Mhm.
At what point do you start looking at hydrogen? When did those conversations with you and Unither Bioelectronics begin? And how did that turn into this magical partnership that we see today?
So very, very soon after I joined, still when I was in my VP of operations role, I knew this was going to be a big part of the future for Robinson. So almost immediately, my VP of engineering and I visited the team that was at the time doing the pure electric version under the United Therapeutics projects, and it was great because they had a really good small team and they had done some really innovative things. Ultimately, I think Mikhail will tell you that they reached the successful conclusion of that phase of the project and realized that for the mission they really needed the longer range. And so it was kind of, we were along the same journey that Mikhail went through. So really over the last 2.5 years, we've gone through this together. And I would say the formalization of our partnership was later in the timeline, mostly because when I took over, it was easier. And for the first year, it was trickier because, I didn't have all the control of signing major agreements and things like that. But once I took over, it was a very quick process to get it all in place. And this is a really great way to look at it. That they have made so much progress. His team, he's hired the right people, he's invested in the right partnerships to where they don't need a lot of our help today. There's areas where we consult and provide support for certification, documentation, or arguments about system safety analysis. These are very specific things in CERT, and then a lot in regulatory relationships where ultimately we're going to collaborate on the certification of this project with the authorities. So we do that kind of support. But the big thing for us is to make sure that when they really get the success and the mission, circled the way they need, we can productionize it and we can turn it into a product that is field supportable, is scalable and distributable. We have the largest distribution of anybody in the entire general aviation industry. We've done that kind of incrementally for 50 years. So because of that, we think we're going to be the right people to help really scale this. And people aren't even thinking. I mean, if you look at the other folks in this industry, they're trying to scale from overhead and indirect expense. Like they're spending a ton of people cost to do that. It makes the business unwieldy and ultimately unprofitable. GA is best executed, best scaled with partnerships. And so we've demonstrated that through our third party dealers and our third party service centers. We have a really great kind of symbiotic relationship with them where their success is our success and vice versa. And so I think we're going to bring that to bear on this problem and love what the team's doing there. I think we're having some really great foundational learning that informs the R66 project that then will make it a much more commercially ready and scalable solution. So we're really excited about that partnership, and they've been flying the last couple of weeks even more, and it's exciting to see how much work the teams put into to really making this a winner. You know.
Yeah. I couldn't agree with everything you said more. I wonder, were you at some of the flights in Southern California?
No, actually, so it's funny. All the work they had done in terms of the major milestone flights occurred before I joined, and so I watched from a distance as an industry player. Mike Hirschberg is a good example. All the publications they put out, and Ken Schwartz did a great write up of this multiple times. So all of those I read from a competitor perspective back when I was within the Bell team, and I think that's why these industry publications really matter. Is it kept me aware of how it was progressing. So when I came in, it wasn't like something I had to learn from scratch. There was a lot of great information out there from technical heavy publications like Vertiflight and so on. So yeah,
It's my favorite magazine. And I don't know if you know, we haven't really announced this yet because we've been so busy, but Mike Hirschberg and Ken Swartz have just joined the High Sky Board of Directors. So we've been
awesome.
talking about, yeah, so we've been talking about how we can kind of revamp their authorship. They are both fantastic writers.
Mhm.
And I don't know that either of them are still writing for Vertiflight. They may be, but it's definitely going to be scaled back. And like, we are not losing that expertise. So I'll
Great.
just kind of ask you, what would you like to see? No, forget about High Sky for a minute. If you could see Mike and Ken continue writing, what do you want to continue to read, like specifically?
Sure. Yeah, I think one of the big areas that we often at the helicopter journals and helicopter type industry publications, we just touch on component. As an example, even in today's generation, there should be more writing about turbo shaft engines because that's a piece of today's critical needs all across life saving industries and military and all that. And we don't dig in enough on turbo shaft. There's not like a publication that hits turbo shaft engines, and that's really important. And I think it will be even for turbo generators on programs that will use hybrid capabilities. So I think there needs to be more detailed discussions about the components and about the subsystems that make this possible. So, for example, in the hydrogen space, I think people should do a lot more detail work on burning of hydrogen and a lot more work on the fuel cells, which we really believe the fuel cells are the way to go. But there's lots of reason to dig into both and to talk through the storage discussions and the difficulties in containment and hazards related to it. I think a really good discussion is going to always cover what are the hard technical problems people are trying to reconcile. And I don't see enough of that. I don't see enough discussions of we're going to have to mitigate one that is an interesting one for hydrogen is pinhole leaks in containment ultimately can lead to pinhole flames. And so you have to deal with the in barely visible or invisible leaks from all this is going to be something we have to really monitor and manage. And you think about those things, they're different than fuel leaks on a helicopter today, but someone should write more in-depth and thoughtful, balanced, I'd say. I mean, the way we look at these is it does no one any good to only be positive all the time. We need
Yeah.
to have engineers thrive on fixing things and improving. So I think it's a really important value that Ken and Mike, and they're both in positions to appreciate that nuance. So that's why I hope they would dig into is some of the component level items and some of the unique areas that need to be reinforced, the specific issue papers we'd expect from the authorities, all that.
Thank you. That is invaluable feedback. Thank you so much. I can't wait to play this for them because we've been having this discussion. I have to tell you a funny story. When we were all in Bromont, Mike and Ken and I, we all shared an Airbnb, and so we were together for a few days, and we've all known each other for many years. But we all were excited to meet you, and we were sitting there talking. We thought, "Gosh, David, he sure is really personable and cool." but we didn't know that you knew who we were. So now that because when I met you, so that explains it. Because we thought, well, he's just the most laid back guy and so open. I'm not
Oh, I
saying
know.
that you're
I
not.
know as many. I know as many people as I can in this business. It's important to always know who you're talking to and their background if you can.
Yeah, well, and it's just really, validating to know that, we're teaming up with the right people and bringing the right people on our board. So it's really kind exciting to see it shape up. So let's talk a little bit about, manufacturing. You said
Mhm.
something on Wednesday, um, to come tour LA. We're gonna make that happen. As somebody that came out of manufacturing where, we produced like 30 aircraft a year or a month, to you, what is high volume for Robinson per month, per year?
Yeah.
Yeah, do you want to scale that higher or do you want to get better at certain things? Is there plans for robotics? What does that look like?
Yeah. So first thing is, I mean, Robinson is in GA the most significant manufacturer of components and then aircraft ultimately. And we set the record for the most in civil. We did 896 aircraft in 2008. And
Nice.
what's interesting is people look at that and they think, 896 is a lot. Then you started making less because of the financial crisis changed the market a bit. Ultimately, we are making more today than we made then in terms of total equivalent produced components because the fleet's grown so much. We
Mhm.
have 11,000 aircraft roughly out there flying every day, and those aircraft are producing a demand for rotor blades, transmissions and gearboxes, drive shafting, major components and structural frames. All that is done at just massive, massive rates. So when you walk the factory here, you'll see both the easiest example is you'll see machine parts that feed all of those things.
Mhm.
They're the hydraulic servos, for example. We have forgings that make the bulk of the bodies, and then a big piece of steel. And yesterday, I was showing folks that we have multiple back-to-back lots of hundreds and hundreds of the core piston, the steel that makes that, and they ultimately turn into those servos. And so you think about that scale; it's just unbelievable the amount we do. And so no one else touches that. And what I would argue is we still have a lot more capacity here. My machines generally go dark at about 3:30 in the afternoon.
Oh,
So they
wow.
work really one third of a day for most of them. We have a small second shift that does about 60 people versus 1,100 on day shift. And so when you consider that, you're like, gosh, that's a lot of open capacity. And we plan to fill it. And we're constantly improving the utilization of the shop by taking older equipment that's maybe specialized and can do one thing and putting it into a multi-tool that can do more things. And then you mentioned robotics. I think robotics is a really interesting topic. We are probably one of the more nuanced and experienced now in robotics. I've got two successful robotic cells and a third that is successful but not approved by the local airworthiness people and the EPA, which is like a giant debacle. It takes forever,
Mhm.
and it's silly because this is safer, cleaner, better for the environment. And I'm waiting more than 600 days just for just for the LA area approval. So it's quite painful. But my point on that is we have roboticized things that matter for the following. They are injury risk. That's the first filter. Second, they reduce and diminish what we consider to be a very mundane and dull job that that employee can be doing something more interesting and more valuable with their time. So two examples, blade weights. Every blade, we make thousands and thousands of blades, and the blade weights for those are little tiny pieces of metal that are fairly easy to machine. We had one person doing that for the last 52 years. That now is a little robot that grabs the part, puts it in the machine, closes the door, and pushes the button, and does that over and over and over and over again, 3 shifts round the clock until we run out of metal. Like that is the dynamic that we see robotics playing in our future. It didn't take a job. It took that same person and made their job more impactful and valuable. And I think the same thing goes. I've got a really neat AI-driven sanding cell that we partnered with Gray Matter Robotics, a really great startup in AI-enabled processing. And their machine is actually being turned on this week for production parts. We've been doing development stuff. And it's exciting because you look at that and you're like, that is another great one where I have people that to make thousands of main rotor blades, you got 13 feet long and some of the blades, and they're hand sanding all of the area of it so they can prep for the primer and the paint and the
Mhm.
follow-on coats. All that can be really damaging on joints, wrist injuries and elbow and shoulder. So we wanted to eliminate that risk as much as possible. But here's the learning. That system can only do 80% of the main rotor blade. The other 20%, it destroys the blade. We've done it too many times to, I can tell you, luckily these were all blades we are going to cut up anyway, but they destroyed a lot of blades. And so what I tell people is robotics will not absolutely end to end change manufacturing. But if you're smart and you are patient, you can find places where it does really important things and then allows your people to do other and more important things. And I think that's kind of how we look at it. And yeah, so the years to come, we'll build 1,000 aircraft again. We'll take care of probably at that point 20,000 aircraft in the fleet. And there's a lot of exciting things that enable all that. But yeah, we love manufacturing here. That's the core of our business, you know.
Yeah, and that's always where I was drawn to. And gosh, it was before COVID. I was actually doing some consulting work with another. It was the Advanced Composites Manufacturing Association at the ACMA,
Hmm.
and they had an aviation division. They had lots of members. It was all composites, but they wanted to ramp up some advanced air mobility stuff. So we collaborated with NASA and did this big event where we brought automotive manufacturers together with aerospace manufacturers. And we were, trying to make the argument. We did make the argument and have lots of speakers that um, if aviation even produced even remotely like automotive, then advanced air mobility or manufacturing would take off. But there was such a knowledge gap in, around AS 9100 and just kind of where to start. And, I kept thinking we need somebody, and Icon Aero, Kirk, I can't think of his last name, rest in peace, recently passed away.
Yeah.
He was, getting involved in manufacturing for AAM. And we were saying, we need to have legacy. I consider Robinson a legacy VTOL company, but we need legacy companies to be getting into the manufacturing. I think that was more feasible than looking at automotive, just because automotive, it's such a shift in kind of culture and the way things are done. So I'm excited. Do you see, so let's say that the R66 is powered by hydrogen electric. Do you see certifying that and selling that system to customers? Or do you see, I think I asked you this
Yes.
in Canada, and I want to ask you again though, do you also
Yeah.
see Robinson developing its own VTOL? And would you put wings on it? Would it be, the same? It would just be a hydrogen
Yeah.
powered VTOL?
Yeah, so I think the missions that we excel at and that the product will excel at are ones where you need to hover. And if you ever need to hover, you need a helicopter. A wing is actually generally counterproductive there. There's a
Hmm.
few examples in military where they put wings on so they can put like weapons pylons and or like detection systems or whatever. And usually you take a big hit about your hover performance because you got a wing under it. You don't have
Right.
the downwash. So I think ultimately I've been through those experiences. I was there when the Pharaoh program at Bell was a armed recon helicopter they were working on, and it had two different versions with different lengths wings because the Army needed sometimes to hover a lot, sometimes to put more weapons and go faster. I mean, all these things are trades that are really well trod, and that's basic aerodynamics really. So ultimately, if you want an aircraft that can go ultra long distances and do it fast, a tilt rotor is a really great compromise of solutions. And the high speed VTOL that Bell's working on, where they stow the wings, stow the rotors, and allow for it to get effectively a cleaner drag picture, that's an exciting development. So I applaud those guys. Super excited that they got some funding on that, and I hope they keep it up. But ultimately, that's the way it looks. Is if you need to hover, it's a helicopter. If you need to go long distances, moderate speeds, it's a tilt rotor. And if you go, long distances, maybe a high-speed VTOL or an electric airplane are the better solutions.
Hmm.
Anything else? And I mean, I've studied this really in depth. I spent multiple days with several different distributed electric folks. Those architectures really don't do what people say they're going to do, and so it's going to be a problem for the industry when all that inevitably deflates due to math, physics, and economics, and not any opinions. It's all just brutal truth of numbers. And down the road, what I think we'll do is we'll offer a zero emissions way to deploy VTOL necessary product over moderate ranges, so up to 200 nautical miles pretty easily. And I think that solution will only get better. And then you go down the path of, okay, well, what use cases does that unlock? We've had a lot of customers reach out to us with some really interesting ones. Think about like an area where you have military aircraft carriers, or you have aircraft out in the world that are large super tankers. They have the onboard capability to either house hydrogen or produce it.
Yep.
That's the really cool thing, is future
Yep.
localized production, and could do that with green sources, nuclear reactors and things like that. If you produce this capability, either through those already very difficult, unique environments where our aircraft thrive today on the ocean, we have a lot of aircraft that live on the ocean. They're going to do really, really well there. And the same thing goes, we have folks in the minerals industry, mining and the like, that are so remote, but they need the ability to rapidly put someone in an aircraft and get them to medical care, or they need a core sample taken to a test facility, or get a drill bit, that's a piece of specialty equipment. And they can do that with effectively a tethered, ready R66 hydrogen fuel cell aircraft, and they're just producing hydrogen passively. And if you look at how almost every industry has cyclical production and consumption of power, so as we go to localized production of power, things like large data centers that may be backed up by big nuclear reactors. That's an Amazon story. That's a future Google story. If you think about that, they're going to probably see AI demand and consumption that is time zone relevant. And so in the periods where that base load isn't needed, generate hydrogen in a clean way, and then have that as that major natural resource for the region. And I think that's the kind of thing we see as the future. And GA is the perfect place to do that, because we are not so massively demanding as commercial aviation, nor are we so massively demanding as military. We can focus on build this outright and do a lot of unique specialty missions with localized production of hydrogen, localized production of renewables of various types. And I think that's the kind of stuff that should meet much of what customers are looking for in the AAM, UAM world.
Yeah, I agree. You said so many things that we talk about often. I don't know if you caught a gentleman named Chris McWhinney's presentation from Millennium Rain Energy. I don't think he got into this on Wednesday, but they're producing hydrogen. They also dispense it, but they're looking at working on helping with data centers and backup power production and those sorts of things. And it's going to be such an important piece. And I can't wait to see the democratization of energy and power, especially living here in Texas and somebody that experiences power outages often. Yeah, I usually have to tell people if I ghost you in the middle of a podcast interview, it's because our power went out. But it hasn't
Oh,
happened,
wow.
knock on wood, in a few days. Yeah, I mean it's a few times a week. So those, and it's the Robinson does its function, and even if in advanced air mobility, let's say if you're using the sort of you know it from to fly over traffic use case,
Yeah.
or even maybe a medical or a car crash. Typically, and I'm in Houston, it's not that you need to, travel supersonic. The reason it's going to take you so long is because of the traffic. So even if
Yes.
you're not going Mach 2, you're still going to be going much, much faster than if you were in a car. What is the speed that most of your
Yeah, so
missions fly
here's
at?
a really hilarious example, and I had this long
Yeah.
discussion. I won't tell you which public eVTOL company I spoke with about this, but I went and I saw their facilities. I mean, we've been in a lot of collaboration with the eVTOL companies behind the scenes, and when I visited with them and they visited us, we talked about how they spend all this time making their airfoils and their surfaces of the fuselage smooth and pristine to reduce drag. And ultimately, as an aircraft, they fly the same speed my helicopter does, about 120 knots, 110, 120. And if you're flying the same speed in our aircraft, we find that like the cost benefit of having fasteners that are flush, smooth, and low drag actually aren't worth it. And you
Mhm.
spend a lot more time training people, doing repairs. They're expensive fasteners. Countersunk fasteners are expensive, particularly countersunk on carbon fiber, very expensive. So
Mhm.
we don't mess with that silliness. That's how we've scaled. And I think that's
Mhm.
a good example where it's so attractive for people to go and build the best, amazing Swiss watch. But if the thing only goes 120 knots, you don't need those fancy fasteners and you'll regret it later. And so our example, I think, is that in this space, it's a lot of claptrap for conversion or carry in lifters when none of that's useful once you get on wing. So instead, a helicopter is always on wing. Our rotors are a
Mhm.
wing, and so you got to think through what's the efficiency. And back to this whole argument of if you ever have to hover at all, which all of these have a phase, they're hoping it's seconds, but in practice it won't be seconds. It'll be dependent on air traffic and depending upon as you're coming in for a landing, you might have to divert and come back. There'll be a
Mhm.
lot of heavy time on those thrust borne modes. And if they ever have to do that, they're going to be sorry. They're lugging around a wing right underneath all the lifters, and all those extra lifters with small discs drive a ton of power draw,
Mhm.
really damaging batteries. So I think ultimately we really love our chances because physics is on our side.
Mhm. Yeah, I mean, very good point. I would argue that I won't name any companies either, but I would argue that having people's travel data around the city is less valuable than having the data for what the existing VTOLs are doing. I think that's more
Yes.
valuable. You know
Yes.
what I mean?
Yes.
Because you can
Yes. Yes.
apply
Yes.
that because you're going to know what is going to happen in reality. Um,
Absolutely.
and perfect example is not. I live right by Hicks Airport, and there's a helicopter services not even a mile from here. So, and they have three
Hmm.
Robinsons. And my daughter just said yesterday, because I was telling her I was going to have you on the podcast today, and she said I have a hard time telling the difference between helicopters. They all look the same to me. I said no, they don't. They look the same because I said let's think of the ones we see every day. I said, do those look the same? And she said yes. And I said, well, they are the same. Those are all Robinsons. And then I pulled out I have our bird of flight calendar on the
Yeah.
wall right
Yeah.
next to our kitchen
Yeah.
table. So I pulled that. I said, now do those look like the ones that you see? And she goes, no, those all look different. And then she came to the page with the Unither. It's got the two red
Yes.
ones from tier one and then
Yes.
the white one that you guys did with Unither. And I said, now she goes, now these look like the same. I said, those are all Robinsons. She was like,
Hmm.
okay, I see what they look like. So to your point, um, we see them all the time, not
Hmm.
just from that, just from that airport, but all the time. And I've yet to see a VTOL fly somebody over traffic just for the sake, and
They can't
personally,
do it right now. It's harder than
yeah,
people realize. I mean, this is
it's
part of the problem. Yeah.
it is. It's really hard. Now, yeah, it would be great in theory, but I think your data is going to be so critical for public acceptance, and for organ delivery because they're going to want to
Hmm.
see something tried, true, and trusted. So I think what you guys are onto is really going to be the winning factors. You have all of the things. You have all of the things.
The beauty of it
What?
too, just to point out, is
Yeah.
like almost everything that I build a lot of is identical for the hydrogen fuel cell version versus the conventional jet fueled version of the 66. Because really, the heart of the helicopter takes power from something and
Hmm.
turns it into slow moving rotor above, and then drives it down the drivetrain and uses that to power the aircraft. And I think ultimately, like that doesn't change. All those parts scale, and so we'll build for a number of years. I suspect this is going to be a 30 or 50-year journey of getting industries to sort of go down the path towards a single again, a single variant down the road. For the meanwhile, there'll be a lot of customers who, for whatever reason, choose a jet engine until they're chose, the technology is proven to them. And so
Hmm.
we're going to provide all of that. And it's not going to change our economics much because I buy engines today. I can buy fuel cells. I can buy the motors, and I can do all of that here in the factory quite well. So I think it's going to be an easy transition. And the thing I also tell people a lot, I think it's such an important thing, is operators that fly tourism, that fly major air charter, so like
Hmm.
UAM, the idea,
Hmm.
it is really important that they standardize. And more accidents in aviation, general and commercial, happen because pilots go from one aircraft to another, and they aren't appreciative in the very high workload, high stress event. They aren't appreciative of the subtle differences. Maybe the switches are a little different in one aircraft versus another, or the avionics presentation is different. That matters, and I'd argue it's the same thing. If you get in remember the most disruptive car you ever got into, rental car. You get a rental car, and the gear shifter is different. It changes things. But imagine doing that at 2,000 feet in the air with a paying group of people in the back. That's what we see when people go from a winged tilt rotor thing to a lift and cruise thing to a helicopter. That's not going to work out real well. And I think my argument is the best solution is going to be one that can both do today's tech, which is our turbine engine power or our piston power, and future tech, which are electric and hydrogen fuel cell. And I think we'll be able to offer all of that. So customers can touch all the missions with all the levels of sustainability or economics, and they don't have to change how they fly the aircraft.
Yeah. That plus adding to that, a lot of people don't know what it means to manufacture airplanes or
Yeah, that's
helicopters,
true.
and
That's true.
so you got that data, you've got the
Yeah.
manufacturing experience that I mean, I think it's just gonna be really exciting to watch. How what's the time frame that you think I know this is a really hard question and kind of impossible to say, but what do you hope to see when is the first hydrogen powered hydrogen fuel cell, so hydrogen
Yeah.
electric powered, I know you know, but just for our listeners, hydrogen fuel cell electric helicopter going to be available to, a average, just your everyday rotorcraft pilot?
So I am a very optimistic person. I will say two things about this. If today's conditions and all of my previous experience holds, I think a reasonable timeline is into the decade timeframe. So 2030-ish, 2031 maybe. I think it could go faster. And here's things that could make it go faster. The priority that's being placed on things like light sport aircraft in the Mosaic world, or that are being put on the distributed electric propulsion stuff with the EIPP program and other adjacent things, or even the things related to unmanned systems and the drone dominance executive order. If there were such an executive order that were applied to hydrogen use, consumption through burning, combustion, or through fuel cells, it could go much faster. And as Mike pointed out yesterday in his pitch, this is actually one that's more unified across the regulatory bodies, which is really rare in aviation to have things they agree on. EASA and FAA don't agree on everything all the time. And it's nice to see that this is one where we actually have some general overlap. So it'd be awesome if people in DC say, this is going to be our vision for the future is going to be hydrogen fuel cell powered stuff. And it could be a mix of transportation in the air and transportation on the ground and already transportation on boats. So I think it'd be really great to say, let's go do this. And it's an executive order away. And then a bunch of R&D and national resources. And, there's a lot of universities that can deploy resources to this. NASA certainly could benefit from focus on this. And I would say, let's go do it. And there's nothing that really is a barrier. It's crazy. And then that would go much, much faster. Because really a lot of the challenge, I think, for the next 4 or 5 years is going to be getting some of the corner cases better understood and mitigated. You think of the challenge I mentioned about pinhole leaks and dealing with that, containment issues and packaging those, and all the hazards of refueling and refilling and all that. I think if we had a team across the industry and across the industry groups and government groups attack this, I think it could go faster. So 2028, let's do it. I mean, the
I love
Olympics,
it.
let's do it.
Also, very freaking valuable. I don't know if you had a chance to participate in the survey that we did Wednesday. We did the results at the end, but that was exactly the kind of information that we're looking for. Let's do
Yeah.
it. I'm in. I hope you saw Wednesday. We have all of the players necessary. We've got the infrastructure, the regulators, the manufacturers, the fuel cell developers. Everybody's there, and we just need to go together, go to Congress, and make it happen. So to be continued. We definitely will
One
follow up
data
on
point
that.
thing to follow up on is like, so we're trying to find, we've never taken any money from anybody. Our business has been entirely self-funded.
Nice.
Because of where we are in our business, we've got a lot of investments going into our R88. We got a lot of business going into our unmanned division, and we have a lot of work going into these advanced propulsion derivatives. If there were grant money that was available for electric and hydrogen production and development here in the US that didn't flow immediately to, SPAC related startups,
Yep.
we would really be able to accelerate and supercharge our work. I think it does help. And we've never taken money, so this is like the first time we'd ever consider doing it, but it would help because I'm putting every dollar I can to drive a responsible business into R&D, and I just don't have enough resources today to do the things that I would love to do with all of the hydrogen systems down the road. So it's an example of where government can make a difference on how small businesses run their P&L if we had just a little bit of help here. And I think that's something that my Tuan from my electrification team is looking for, private and public opportunities to get grant money out there that can could accelerate this stuff, all of it.
Yeah. Well, I'd be happy to chat with him or her. I
Yeah.
didn't catch the name.
Yeah, Tuan. Yeah, he's
Tuan,
a
okay.
former Rivian, Tesla, and Supernal. So he's got a lot of history
Nice.
working in this space and brilliant. And he's been very closely tied in with Mikhail and the team up there and Bromont. So great resource for us and super happy to have him on the team.
Very cool. Yeah. So that what you just said is something that has been requested of the High Sky to help organize for a couple of years, and we're trying to sort of navigate what that looks like. What is our action item? What does High Sky Society do next to help get you guys the grant money? I think first. So what would your answer be to that? What do we do
Well, I think
first?
I've seen this more and more. I mean, we also at Robinson's history have never had lobbyists ever in our company's history until this last year, and we felt like it was necessary for some of the work we're doing on the defense side of the business, and that's most unmanned and manned aircraft. so we did that, and it's been very successful.
Hmm.
It is a necessary part of our democracy that if you want focus in the legislative process, you actually have to put professionals at it and spend time doing it. I think that's an appropriate way to do it, and say that High Sky and all of our members can go and say, let's go ask for government appropriations that prioritize this amongst all the
Hmm.
other priorities at least a little bit. So there
Hmm.
is money that can flow in this direction. And I
Hmm.
argue, I tell people why I like this. One of the things is that it goes right alongside investments for AI and data centers that
Hmm.
we know is going to be a big part
Yep.
of our future. So let's team up to say, let's make affordable, more sustainable power
Hmm.
production
Hmm.
locally. And then as part of that, let's explore hydrogen production locally and
Hmm.
infrastructure spend on that. And then
Hmm.
that opens up all the doors for hydrogen as a regular general aviation fuel. So
Yeah.
yeah,
If you think of an industry or an instance where that happened in aviation um successfully with anything with respect to any technology,
yes.
share with me because I'm
Yeah.
very good at rinse, repeat, and apply, the
So
same method.
AUVSI
Okay.
and the unmanned systems side in general lobbied very effectively for changes in laws that supported eventually this recent Part 108 BVLOS release. And so I think
Okay.
these things do work. And before that, there was tons of grant money and R&D money spent, and lots of government resources on
Hmm.
evaluating air traffic management technologies,
Hmm.
working through regulatory bodies to write lower level standards and specs, even just management of the frequency spectrum for command and control. I mean, so that's why, and it came from big companies that are startups, most of them, but like Zipline and
Hmm.
SkyEO and
Hmm.
DJI and all those folks all put resources at it. So I think there's a model for this that
Got it.
could accelerate all of the adoption, I think.
Okay, that is, I'm again valuable. And I wonder if you're talking more about advocacy. Now, being running a 501(c)(3), we panic when we hear the word lobby because we're technically
Right,
not allowed to lobby. You have to
right,
be a
right.
501(c)(6). But I think that AUVSI is a 501(c)(3) as well. So what they
Yes.
probably did was advocacy, which most people kind of, I guess, lobbyists is, I think, is like when you
That's it.
actually,
There's a way around
right.
it. I mean,
Yeah,
I say
exactly.
not the best way to do it is that you build an alliance, you
Yep.
establish maybe a political action committee that
Yep.
goes and provides the funds in a legal and compliant way. And all that seems like what has been done in the drone industry, what's been done previously in our medical industry,
Yep.
air tourism industry. I mean, this has been over many generations, has been an effective way to get just a little bit of a hand, a little bit of help
Yep.
when a critical need arises.
Yep. Okay. That gives us some really good actions for 2026 and beyond. That's something we really want to tackle for you all and make this as easy and limitless and scalable and rapid as we possibly can. So that is really excellent feedback. Okay, so now I'm going to pivot to I've got two last questions for you. First one, I want to ask you what would you tell your 18-year-old self if you could go
Hmm.
back and talk to him right now?
Well, so I'll just lead with saying MIT was brutal. It was definitely the hardest experience I went through, and I was reminded of that. I was at my reunion this summer, and one of my classmates flew a Dragon capsule to the space station and lived there for a while. A brilliant engineer, and she said the same thing. She said, like I've done. She flew Cobra helicopters for the Marine Corps and did had twins as a mom and lived on the space station for a while, and said that MIT was the hardest experience of her life. And so what I tell people is you will survive your hardest experience of your life. And I think to my 18-year-old self, I would have probably reinforced that these are all trials and you will make it through. And I think this is why I think the industry that we're in has a lot of technical trials ahead and a lot of things that are going to be difficult to watch, of implosions of bubbles and displacement of really talented people in many ways. And ultimately, I think it's going to be trials that we have to all be ready to make our way through. So that's what I tell my 18-year-old self. I tell my 12-year-old son that. I think it's the truth.
Yeah, yeah, really great answer and really good advice for your son there. Okay, so what question would you like to ask our next guest? But I don't tell you who it is. Any question?
Okay. Oh wow. Well, you have great guess. I think I would guess a good question would be what they think their family vehicle will be in 20 years? And
Ooh.
talk about why. Because I think, like, I really think about that of what we're doing and whether it's, do we even own cars anymore? Do we have a mix of cars and aircraft that get us from the
Mhm.
distances we need to go? Do we skip cars? And I was staring at a parking lot outside my window, and I think down the road, it sure be nice to turn that into more factory and working space and solve the at 3:30 we clog all the roads around here because of the exits. And I think about all that of like, what if in 20 years that's not the story, and instead our entire urban landscape is a lot more point of use and a lot more on demand and
Mhm.
uh, massive reduction in volumes. And I think it could change everything, and certainly will change air products as well. But so I'd ask them that if they have a vantage point on 2 decades away, what is that going to be like?
You got me thinking now. I'm like, what do I want it to be or what do I think it will be? They're not exactly the same thing.
Yes, but like we make this stuff happen. That's what's crazy. Like
Yeah.
we decide what 20 years looks like. We have all the
Mm,
control, and in 20 years you can go through like 10 careers if you want, and one of them could be the president. And like you could be the
yeah.
person who calls the shots. I mean, so that's why I think these things are really interesting to talk through. Of like, what do we want it to be, and then
Mm.
what do we think it's going to be, and then like close the gap.
I love it. Yeah, we can make the future. What is the saying? The best way to predict the future is to create it. Well, we're going to create the future together, David. It was truly an honor. Thank you so much for being my guest today.
Awesome, great to talk to you. Thanks for doing all this.
Absolutely. Have a good one.